Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. So we from PERTANIAN will represent and will be explained more about Scum from POME. So first we will introduce our members of Group 13, which is me, myself, Muhammad Nur Aiman bin Murad, 203144. The second members, Olivia Janam dari Lalo, 202691. And the third member, Nursofi Alia Binti Shahrul Anuar, 202692. So first, we will introduce, we will explain, we will show you about the table of contents, which is the first content, which is the sources of the waste produced and its quantity. The second process and the second content, which is the process involved to convert the waste into bioproduct. The third, which is the application of the final products. So So first, I myself will explain the first chapter, first content, which is the sources of the waste produced and its quantity. So let's go. So as you can see on the slide, this is this as an examples of scams, which is currently happens in Malaysia. So which is means scum, which is means palm oil production generates liquid waste in large quantity. Liquid waste, which is it means it's harmful to the environment around the mill, which is the mill means in Malay we say kilang or in English we say factory. So let's go to the next slides. So the slides will be explained about what is scum from POM. So scum is a layer of dirt or impurities that form on the surface of the palm oil mill influence POM. The formations of scums occurs when the bubbles rise to the surface, taking with them fine suspended solids. This is because of the presence of oil and grease in the POM, which are not effectively removed during the pre-treatment stage, which is its content in a fat, vegetable oil, food waste, plastic materials, soaps, wax, and many other impurities discharged from palm oil mills. So the third slide, which is the quantity. So in the year of 2004, more than 200, more than 40 million tons of palm was generated from 372 mills in Malaysia. If the effluent discharged untreated, it can certainly cause considerable environmental problems due to its high biochemical oxygen demands, chemical oxygen demands, oil and grease, total saline, as well as suspended solid. The biological oxygen demands (BOD) contents of the effluents range from 2000 to 30,000 ppm, which is about 50 to 60 times stronger than the domestic sewage. The reduction process involves a high retention time at about 100 days for the complete process before discharge. And dislodging process of pond itself is very costly. Current cost is about RM 100,000 per pound, which is very, 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 very costly to some department or some company. So the next one, which is the information. So this is an example of information that I get from Malaysia from article that our PhD or doctor students that do it for its projects. So that's all. The second ones, I will pass it to Olivia Janam dari Lalo. Bye bye.
Thank you, Aman, for the explanation about scum. I will continue with the process that involves to convert the waste into bioproducts. Since that scum is a liquid waste that harmful to the environment around the mill, so it is necessary for us to handle this waste seriously. There is a new technique to convert scum to biodiesel. 6 steps is needed to complete this new technique: filtering, acid washing, acid catalyzed esterification, base catalyzed transesterification, glycerol washing, and lastly oil refining. Okay, this is 6 steps to convert scum to biodiesel. Firstly, filtration. During this process, we separate the large particle in the scum. Secondly, acid washing. We use gravitational settling to convert soap to free fatty acid, FFA. We separate oil from water and electrolyte that are soluble or insoluble in water, and then we remove the tiny particles. Thirdly, acid catalyzed esterification. The top layer's oil was collected. Next, base catalyzed transesterification. We subjected the top layer oil to base catalyzed transesterification processes to form fatty acid methyl ester, FAME. Fifthly, glycerol washing. Glycerol washing was then conducted to help in the separation of glycerol and other contaminants or particles from the FAME. And lastly, oil refining. After extracting the glycerol and methanol from the FAME, the crude FAME was processed using fractional distillation to create high-quality biodiesel. So, this is the related equation of the 6-step converting scum to biodiesel. Soap add with acid will produce salt and FFA, free fatty acid. This is during second step, acid washing. Then free fatty acid, FFA, adds with methanol with help of acid catalyzed to form water and FAME, fatty acid methyl ester. This occurs during third step, acid catalyzed esterification. And then next is triglycerides add methanol with helps of base catalyzed to form glycerol and FAME, fatty acid methyl ester. This is during fourth step, base catalyzed transesterification. Okay, after we complete all the 6 steps, the high quality of biodiesel is produced. The high quality of biodiesel can directly be used in diesel engines. So that's all for my part. I will pass the next session to Sophie Alia. Thank you.
Assalamualaikum and hi, I am Sophie Alia with metric number 202692. As the last presenter, I will proceed to discuss the application of the final product of the scum from palm oil mill effluent, which is biodiesel. Biodiesel is basically the final product that comes out from the process that has been explained previously by Olivia. Palm oil biodiesel is a renewable fuel which can be an alternative for diesel fuel. This alternative fuel has become imperative to reduce pollution and address the problems on fossil fuel. It has potential as an energy source and alternative diesel fuel in terms of its performance, environmental impact, wear characteristics, and economic considerations. As we know, palm oil plantation and production are a major industry in Malaysia contributing to the economic growth and development of the country. According to Masarov et al. 2015, in order to boost domestic consumption of palm oil, palm biodiesel has been served as alternative forms of energy and are currently being studied particularly as a diesel fuel substitute. It is said that palm biodiesels are environmentally friendly and less emissions are produced than conventional diesel. According to the present study, performance and exhaust emissions using palm oil fuel and its blends with conventional diesel fuel in stationary diesel engines are comparable to those of conventional diesel fuel. Furthermore, palm biodiesel has numerous advantages over conventional diesel fuel. For example, no dark smoke produced. Second, much lower carbon dioxide and carbon monoxide emission. Third, no engine modification needed, where analysis also showed that palm oil does not seriously affect engine and bearing components, does not degrade lubricating oil, and produce comparable amounts of carbon deposits. And best of all, it comes from a highly sustainable and renewable sources. Suzik and Atikur Rahman Han 2018 has claimed that palm biodiesel could help the Malaysian government to reduce its greenhouse gas emissions since biodiesel will offset diesel tailpipe emissions. It allows Malaysia to reduce its reliance on fossil fuels and mitigate its greenhouse gas emissions. Moreover, prosperous biodiesel industry also can expand employment in rural communities. In conclusion, economic prospects for these palm biodiesels are not yet promising because of factors such as production costs and fuel economy. However, if research to reduce production costs is intensified, then energy produced by engines using palm oil are likely to become economically competitive with virtually all other forms of energy. I think that is all from me. Thank you.